I definitely didn't write it for the first time. But I also know exactly what's going to be on your test. All of this. So I want to start with the types of reactions. Okay. We have 2 types of compounds, 3 types of compounds technically. So does anybody know the 3 types of compounds first? You can just say it. I don't care. And it doesn't have to be right. I'm not going to give points. What always starts with an H? Oh, acids. Acids. You're thinking hydrocarbons?
Yes.
Yeah. That's a type of ionic covalent compound. Okay, so we have ionic, covalent, and acids. Acids are just ionic compounds with an H in front. So, ionic, what does it contain? What makes up an ionic compound? A metal and non-metal. We have a plus and a minus charge, right? Metals are always positive, non-metals are always negative. What about a covalent? Non-metal and a non-metal. Metals do not bond. The reason for that is because if I have something with a negative charge, that means I have more electrons than I do protons. Protons do not change in number. They're your atomic number, right? Protons never change. They stay in the nucleus. But I can have less or more electrons than I have protons. If I have a positive charge, I have more protons than I do electrons. If I have a negative charge, then I have more electrons than protons. Okay. If I have more electrons than I do protons, that means I can give away electrons. Okay. If I have 2 positives, I have no electrons to give away. So they cannot bond. The way elements and atomic ions bond is through electrons. Okay. Metals, when I mix 2 metals together, all I'm doing is I'm pushing the atoms close to each other. So if I have like an alloy is a mixture of multiple metals, like steel. Steel is like iron and aluminum, iron and lead. I'm taking lead atoms, singular lead atoms by themselves, and I'm taking singular iron atoms, and I'm pushing them really close together. That's it. They're not creating a new chemical. Okay? They're staying as their atoms, they're just really, really close together. Okay. When I have 2 negative ions, what they're doing is they're swapping electrons, because they both have electrons to give. That's why they share electrons. When they don't share electrons, they're just swapping them back. Okay. When I have an ionic and a covalent, my negative ion or my anti-ion is giving an electron to my positive to create an equal neutral compound. So I said an acid was just an ionic compound, right? It's just H and a negative. That's it. So an H is always positive, right? Positive one. No negative. So it's still just an ionic compound. But I told you that an ionic compound that's an acid has an H front. That's it. When you move further on in chemistry, if you do, or if you move further on in biology, whatever, you will learn that an acid is not an acid. So there are different definitions of acids. We're going off the Arrhenius definition. He's a guy. And he decided that if I put an H in front, if I have an H in a compound, and I put the H in front, if I identify it as an acid, then it's an acid. We also have the Lewis definition, which says that you don't have to have an H in there at all. It just has to donate or accept electrons. Don't worry yourselves about that. I just tell you because an acid is really no different. Don't freak yourself out by what an acid. Okay. So if I have 2 ionic compounds in a reaction, what type of reaction is that? I'll draw it. This is a chemical reaction, but every reaction is a chemical reaction with my chemical change, right? If I make new chemicals, it's a chemical reaction. But a plus minus, what I mean here is just an ionic equation. So can somebody give me an ionic compound? It doesn't matter which one. Calcium's positive. So I put calcium over here, right? What do you want it with? Name a anion. What side of the periodic table do you look for anion? Left or right? Right, right of the stair step, that black line, those are your anions, your negatives, your non-metals. So give me a non-metal. Chlorine. Now we need to make sure the charges are right, right? Because I want this compound to be neutral. Calcium has a what charge? 2+. Chlorine has a what charge? -1. Is this equal? -1 to a +2? No. What do I want? How many more of what do I want? That's a negative. Okay. Which one do I want more of? Do I need more of? Chlorine. How many more? 1 more. And I multiply right 2. I bring that 2 down to the chlorine. I bring the 1 to the calcium. Calcium stays the same. Okay. So that's 1 ionic. Give me another one. Metal and non-metal. We'll balance it together. You can just name 2. Okay. Sodium has a what charge? That's 1. Oxygen has a what charge? -2. Which one do I need more of? Sodium. How many sodium do I need? 2. Right? Bring that 2 down. Bring the 1 down. Okay. So those are my 2 compounds. If I have 2 compounds, what kind of reactions? double displacement. In a double displacement reaction, I take my positive charge or my cation, right? And I do the second anion and I make a new compound, right? So cation is my Ca for calcium. And I need O. Is that balanced? Calcium oxide. Is that balanced? Yes, because calcium has a 2 plus, oxygen has a 2 minus, 1-to-1 ratio. Perfect. What is my second compound? Does chlorine go first? No, plastic always goes first. So sodium, chlorine. That balanced. Yeah. So you've just done a double displacement reaction from start to finish. Okay. So this is just one of our types of reactions. I'm not going to balance it. I just want to name them. So this is our double displacement. Which side is my reactants? Left side. These are reactants. They react. So these have to be my products, right? Okay. Double displacement. So I have a full compound and a full compound that make another full compound, another full compound. Okay. What would single displacement be? So I can take this compound, right? BaCl2. Does that ion have to be a metal? No, we add to it. It does not have to be a metal. It can be anything, it can be an anion or a cation. So CaCl2 plus, let's say iron. Okay. I'm going to teach you from it. I know that iron went with chlorine. What type of molecule or what type of atom is iron? What kind of atom is iron? Non-metal, metal. Can you wear it? Can you wear iron? You can wear iron jewelry, right? Right? You can wear iron rings. They're gonna be nasty in some days, but you can wear iron rings. It's soft. It's a metal, right? This is my cation. It has a positive charge. Do I know iron's charge without seeing it in the compound? Where is iron on the periodic table? Then the transition metals. What do I know about transition metals? And their charges. They vary. So I cannot tell you what iron's charge is unless it's in a compound, unless it's inside a compound. Okay. So let's do these charges. You told me calcium was a positive charge, right? So this is our cation, and chlorine is negative, so that's our anion. The way that these work is by swapping out whatever you have with the new one, right? Because this is a metal, I have to swap my metal with my compound and make it my new ion. Okay. So that's why iron goes here because it's positive. If iron was a negative, if it was an anion, then it would replace chlorine, and chlorine would become the ion. Okay. That's the only reason I know that it goes with chlorine. Okay. The reason that I know it's FeCl3 is because in my head, I said I want iron to have 3 plus charge. That's it. You wouldn't be able to, you'd have to make up whatever charge it is. Because iron does not have a charge just sitting here. This is a molecule. Molecules, like anything else, any other compound, have no charge, right? It has the possibility to have a plus charge when it comes to ion, when we break everything up and remix it. But sitting here, it is neutral, okay? So I can't tell you its charge without just assigning it one when I do my flip, okay? So I've assigned it a 3, so it's FeCl3. So if I named all of these, starting from the left, what are my names? What's the name of this guy? Why isn't it? What kind of compound is it? Do ionics have prefixes? No. The reason ionics do not have prefixes is because I know ionics charge. I know ionic compounds, I know their individual charges when they're ions. Even I can figure them out if they're a transition metal. And the reason that is because I have to make this neutral, right? When I create a compound. If I have a covalent compound, I cannot make it neutral. So I have to tell you exactly how many there are of each atom in the compound. I don't have to tell you with an atom. This is calcium chloride. Okay. Does anyone want to try iron? So if it was named, I would say iron 3. Yes, but it would be iron 3. You have to tell me in its name. Okay. And then name this guy, FeCl3. No prefix, right? Ion. Does anyone know why iron is Fe? It is Latin. It's Latin for ferrous. That is the Latin name for iron. It's ferrous. Iron is one of our oldest elements, so we named it with its Latin. There are also already a lot of eyes up there. They're not doing that's how the periodic table is named. So you have to look at what already was there. Yeah. You got Francium, Borean scientists. You pretty much just named it after you, unless it already existed before you. So if you discovered an element, you guys name it whatever you want. That's why we have plutonium. Pluto? Plutonium? Yeah, so I just really like Pluto. Not there. And then calcium, it's just calcium, right? So this is our single displacement, right? Because this guy's single. The loner, like I was in high school, he's single. He goes out with, I guess, a swinger couple. They swing, and then this guy's loner. But this guy, this is a great swinger couple. You just switch. Okay. Little swingers. That's the pictures. Could I do all of this with a covalent compound? Could I do a single replacement with a covalent compound? Yes. The only way that you can do that with a covalent compound is if your ion or your single molecule over here, if this guy was a metal, right? Because then I'd make an ionic compound and then I have my anion over there. That's the only way. If you had a covalent compound with an anion, you could technically, but I don't know how, which one would go with which. I would have to tell you, right? Because you could only guess which one will match up with which, right? But you can't know for certainty. That's two. So those are two types. We have two base types, which I think are kind of the beginning and the end of reactions. What's my beginning? What do you think I mean by that? It's the basis of pretty much every reaction. Synthesis reactions is the basis of almost every reaction. Multiple things coming together to make something. So synthesis just means create. Synth means made, Latin. So A plus B equals C. Okay. The A plus B, these guys don't have to be molecules, so they don't have to be by themselves, but for our purposes, they will be. What's my N when I break something up? Decomposition. What does decomposition mean? Yes, the literal breakdown. It's that was trying to be a trick question. Sorry. Everything technically is a synthesis or decomposition reaction. We have types of synthesis and decomposition reaction. This is a type of synthesis, right? Decomp would be usually we only have one compound in decomp, just because my decomps are by themselves. But I can use stuff to make them decompose. Okay, we have two more. It's the two that everyone forgets. It's the two that you have to know for the test, which is kind of sucks that it's the one that everybody forgets. But they're special. They always have the same products. And you need one. And yes, I named acids for a reason. Yeah. So the acid base or neutralization. I always call it neutralization. You guys call it acid base. Whatever. I don't care what you call it. An acid base is literally an acid. I have an H here, right? That makes it an acid. Plus a base. Bases are recognized by OH at the end. They have a hydroxide. Hydroxide makes something basic. If I can make water, I'm going to. This is just a double displacement reaction, right? Plus, that's your negative anion cation makes H2O. If you write it as HOH, that's fine. No, it's not technically wrong. You're fine. But this is the systemic. HOH would be the systematic name, which would be how it looks as a molecule, or how it looks as a compound. Okay? And then whatever's left. Okay, I have a positive sodium and a negative chlorine, right? And HCl. That is my acid base. So which one's left? Combustion. What does combustion sound like? Explosion. Fire. Combustion is not just when you set something on fire, but it involves fire. Okay. So combustion is always a hydrocarbon. I'm actually gonna write a real hydrocarbon up here for you actually. No reason not to. C5H8. That's my hydrocarbon. Hydrocarbons are organic molecules. You just really like. That's it. Plus, what does fire need to exist? Oxygen, right? Oxygen is diatomic, so it's always O2. It's not O2 in a compound, it's O2 when it's by itself. Okay? So oxygen, if I breathe in oxygen, I release carbon dioxide. And I said if I can make water, I will. Do I have hydrogen and oxygen available to me? Yes. So I will make H2O. Short-term reactions do not always look like this, but this will be what it will take in your test. Pretty much by something that can be collected and then by oxygen. But oxygen likes to bond with other things, so it will break up things to bond.
So we have two oxygens on the side, and on the other side, we technically have three oxygens.
This is not a balance. None of these are balanced.
Okay, sorry.
Some
I
of
was
these
like,
happen to be balanced. Like this is just happens to be balanced the way it is.
yes, I think that's probably what three, the other one was balanced.
This guy's not.
Okay.
I have 3 chlorine and 2. Yeah. I
I was like, I have missed vital stuff, and this is really
No.
bad.
No. This guy is not balanced. This is actually a really long balance. Your combustion and neutralization reactions are going to take a while to balance. This guy is the best example I can give you because it doesn't need to be balanced for balance, right? Isn't this lovely? This is great. They're not going to give you this. This takes zero thought. You just need to remember what the products are. Okay, that's what's important here. This guy is always hydrocarbon plus an oxygen equals CO2 with water. You have to remember this the entire thing. This guy, if you can figure out that this is an acid and this is a base, you can figure out products, right? Because it's just dealt with this reaction. So with these guys, you don't have to name hydrocarbons. By the way, you guys don't know how to name them. They're named a totally different way than anything else. Don't have to. But if I told you that this was propane, you would just have to believe. If I say ane at the end of something and I don't tell you what its formula is, it's hydrocarbon. That's the little gift I'm going to give you. I don't think they would be that mean to you and not tell you which one is which. But if they don't, if it has ane at the end, it's your hydrocarbon. This I believe should be done. It's not good. Can you propane? No, I have to. I'm organic conversation. Yes. No. That's probably too. Anyway, so the next step of knowing these guys, other than being able to name the compounds that are in here and understanding which compounds are what, is the whole balancing act, right? So if you can recognize a reaction, you're already halfway there. The other half is understanding how to balance. A lot of people, when they start balancing, we kind of go over balancing a little fast because we want to get in what type of reaction or what and why they happen. But so everyone does it a different way. And even your professor will probably do it a different way than I do. But I'm not saying to abandon your way, but I try to make this as simple as possible. So let's do actually kind of a difficult one. Sorry. So C6H6. And hydrocarbons don't work the way you think they should, so yes, that is balanced as a compound. O2 equals H2O2. What kind of reaction is this? Question. Because I make CO2 and water. Should we add you first? And then we'll sort of work together. I list all of my elements in the middle. If you write H2O like HOH, that is a polyatomic, right? Hydroxide. You could count a OH as one of these and write OH instead. But because on this side, oxygen and hydrogen are broken up, I don't have to do that. Okay? I think that's what you're counting. So I always start with, on whatever side you're looking at, I look on both sides, right? The element that is not in two compounds. I want an element that's in a single compound on one side. So if I look at my reactants here, everything's neat and tight. Everything only has one element in each, right? Carbon is only in this one, hydrogen is only in this one, oxygen is only in this one. But if I look at my products, oxygen is in both of these compounds. If I balance oxygen first, it will be so much harder because it affects everything, right? If I balance this, it's going to affect my C, and then if I balance over here, then that's in fact that's at my count. Don't worry about it. I will never say to go after one type of element first. Like I'll never say to always do fluorine if it's there. Always do hydrogen first. Always do the one that's easiest to balance first. So I'd probably pick either hydrogen or carbon. It's your choice. Carbon. Okay. So I'm first just going to list all my numbers. I have carbon, 1. I have 3 oxygen, and I have 2 hydrogen. Over here, I have 2 oxygen, 6 hydrogen, and 6 chlorine. So if we want to balance that chlorine or that carbon first, then I'm going to have to make this 6, right? So to make this 6, I want a 6 over here. I have to put it in front. If you put it as a subscript, that's not how compounds work. You're messing up the entire compound. Okay? We have to put it in front. So if I have 6 carbons, that also impacts my oxygen, right? How much oxygen do I have now? Plus 12 plus 1, right? 13. I should have crossed that by 3. I ain't gonna do it. I wanna know, I want you to see. I'll make sure. So that's 13, right? 6 times 2 is 12 plus 1 over in the water. So I have 13 over there. I still don't want to touch oxygen, okay? So I'm gonna go after that hydrogen next. So I have to move this one, right? I want that to be 6. So I need a 3 over here. Okay, I have 6 hydrogen, good. But now I have 3 times 1. I have 3 oxygen plus 12 oxygen, which makes 3 plus 12 is. Okay. So everything is balanced except my oxygen, but I have 2 oxygen over here. Can I ever make that 15? No, 15 is an odd number, which means the only thing for me to do is multiply that one by 2 because I need more hydrogen and carbon, right? Because I'm going to move up those numbers. So these both become 12. So multiply everything by 2. That means that I want these guys to be 12 too. So let's start with our carbon again, right? Carbon has to become what? Over here. 12. So I want that to be 12. Right? And then I need to change my hydrogen. 12 divided by 2 is 6. So this will be 6. So I have 2 hydrogen times the 6. Okay. That changes my oxygen count. I now have 6 oxygen plus 12 times 2 is 24. So now I have 30. Is that an even number? Yes. So that means I can turn this one into 30, right? By putting a 15 here. That's my balance count now. I know that looks big. The numbers are big. Combustion has big numbers usually. The reason for that is because carbon and hydrogen usually go at the idea that for every 1 carbon I have usually about 3 hydrogen. Okay. So if I add up more carbons and I have more hydrogen, but they're not usually at a nice number, right? They're usually a freaking number. This guy, they're both at 6. Probably because they attach to other things. So combustion usually is a little freaky because the oxygen is always going to be a 2 compound. If you get to a number like these numbers, if you ever get to one of these, your number's like 30, stop. Look at your compounds. You do them correctly. That's usually the problem. Okay. Because if you get to 30 and nothing divides, like there's not a common number between any of your numbers out front, look at your compound. You just probably balance your compounds wrong. So we are going to do a decomposition reaction. This is number 3 on balancing equations 1. And so I'm going to do the same thing. We're going to list all of my elements in the middle where the arrow is. So I have a iron. This is what I'm supposed to talk about with the polyatomic hydroxide, right? Because if I write H2O like this, I have a hydroxide on both sides, right? Usually I tell people if I have a polyatomic that stays the same on both sides, I can write it in the middle and I can count it as 1. I don't want to do that in this case because I have an oxygen right here. The oxygen is not attached to hydrogen. If I count up all these hydroxides and then I count up the oxygen, it takes a little bit more time. You can do it. It's possible. Usually just takes a little bit more. So I'm going to write my oxygen and my hydrogen separate. That should be all of my elements, right? So how much iron do I have on my reactant side? 1. How much oxygen? How much hydrogen? 3. What about my other side, my product side? How much iron do I have? 2. How much oxygen? 4, right? Because I have the one over here. And how much hydrogen? Now, this is the same thing. I have oxygen and 2 compounds on the same side. Last to balance. So let's do iron first. I usually like to start with my metals on the one. So this guy needs to be 2, right? Match my other guy. So I have to put a 2 right here. That changes oxygen and hydrogen to what? What's my oxygen count now? 6. And my hydrogen count? 6. Okay. So my iron is balanced. What's next? What do you want to do next? Should you do oxygen next? No. 2 compounds on the same side. So hydrogen, I guess, is our only answer. So I went to that to 6, right? So I put a 3 here, make 6. Now I have 3 oxygen and another 3 oxygen, right? 6. The balance. Okay. Not too bad, huh? Yep. That was. If What type of reaction is this? Decomposition. Good job. Because I have one thing and two multiple things. This keep going. This could have a lot of compounds in it on the other side, on my product side. Doesn't have to be two. This one looks long, but it looks. This is the second side of balancing equation 1, number 10. Type of reaction is this. Double. How do I know it's double? I do compounds. They switch. Double displacement. So first thing I'm gonna do is I'm gonna write those elements, right? These vanadium. You don't even know that, but it's vanadium. I like vanadium. It's fine. Fluorine, hydrogen, iodine. On my reaction side, how much vanadium do I have? How much fluorine? Hydrogen? Iodine. On my product side, how much vanadium do I have? How much fluorine? How much hydrogen? How much iodine? Do I have the issue where two of my compounds on one side have the same elements in it? No, I do not have that issue. So pick whichever element you want to bounce first. Vanadium. So vanadium means become 2, right? On this side. So I put 2 here. Which makes my fluorine what? 10. Okay. What do you want to do next? No wrong answer. You want to do fluorine? So what does fluorine become? 10. So I put 10 here. That impacts what? Hydrogen. What does hydrogen become? What's left to balance? What do I need to do there? You can fix. You can pick one. Hydrogen needs to become what? 10. So I put 8. Which impacts iodine to become? Storm. If I put a 10 on this guy, not only would that unbalance everything I had, but let's just pretend it would still be balanced like that. If I did 10, 10, 10, and 2, would that be my final answer, my final balance equation? If I had 10 here. Don't look at how many elements I have, just look at my numbers in front. No. If they have a common factor, we remember that from algebra, a common factor, i.e. they can be divided by the same thing, you all bring them down to that number. 2, 10, 10, and 10 can all be divided by 2. So it becomes 1, 5, 5, 5, right? There's a 10 there.
So the only time you do that is when there's a number on all of them.
That can be divided by the same number. If I have a 6, 6, 1, and a 6, that one cannot be divided by 6, so they stay the same. Okay. The only real reason that you would bring that ratio down is you miscounted. You went over how many you need to do, like you overworked the equation. But that happens all the time, right? So these guys. Does that kind of balancing what I'm doing make sense? Okay. A lot of people will write like the elements here and the elements over here, and they'll write the big line down, and then they'll do that. That's also allowed. I don't care. But a lot of people, when they do that, they don't match them. They'll do as they present the problem, and then you'll look at the numbers side by side and go, oh, those don't match, because they're different elements. They're not going to match. So I like to be pretty in your face about what elements. So if I named all of these compounds, what would their names be? First one, ionic or covalent. I'll give you a hint. If you don't see it on the non-metal side, it's a metal. So if I have a metal in a compound, what does that make it? It has to be ionic, right? If I have metal in a compound, my only other choice is covalent. There are no metals in a covalent compound. So this has to be ionic, which means I just need to tell you what's in it. So I said the name of that was vanadium, right? Where is vanadium? It is a transition metal. I do not know its charge, right? So I have to figure out its charge by what compound it's with, or by what element it's with. Fluorine has a charge we know, right? What is fluorine's charge? -1. I have 5 fluorine. So I have a -5 on my anion side, right? So what does vanadium have to be? An ionic compound, it has to balance to neutral. So what does vanadium have to be? What is vanadium charge? +5, right? That's why I need 5 fluorine. So this is vanadium, B. Erase this, so. Vanadium, what? Fluoride, Fluoride. Most people thought fluoride like flour, FLOUR. I did about my bachelor's degree. Okay, you get points off, but if you get far enough up, they no longer take the points off because they're not looking. Okay, that's my winning, that's my success word.
Just keep being wrong.
Yeah, just keep being wrong, and one day it won't be a bad thing. So, vanadium 5, fluoride. Okay, B is 5. Okay. You're never gonna hit 10. You hit 10. Either you did a chemical reaction that is not at your level, or you really messed up because nothing has a charge of 10. There are only 8 valence electrons. You cannot have a charge of 10. Okay. So let's move on to that one. Covalent or ionic. Is hydrogen a metal? Yes. Hydrogen is a metal. It's on the left side of the periodic table, right? It's an exception with certain elements that it becomes covalent. It's very weird. It only has 1 proton, so it likes to do what it wants to do. But in this case, it is ionic because it's a plus and a minus, right? So I'm just gonna tell you what's in it. So what's it saying? Hydrogen. Iodine. I means element. Do not, if you put "ein" or whatever the end of that element's name is on periodic table, it is called. Okay. Hydrogen iodide. That's an acid, isn't it? So you named it like an ionic. What if I named it like an acid? It's an elemental acid, which means binary, right? So I put hydro in front. Hydro. Because it's just an element. Iodine is just an element. We have a hydro in front. Iodide. Yes. This is not your quality condition. It's not very. This is spelled. This is the ionic name. This is my acid. Do not put the ionic name on your test. If you want to name this. Put the acid name. Hydrotic acid. Okay. V2I10. I keep the charge of vanadium from one to the other. I know what you're looking at. You're saying iodine only has -1. It's just the way this compound works. If I were to break this compound down to what it should look like, it should be Vi5. Or yeah, Vi5, right? But this is the systemic name. This is how it looks in real life. So we're gonna have to be this is for you, Luda. You have 2 compounds next to each other with making one compound because I wrote them all together. V2I10. Okay. But this is still vanadium 5 iodine. Don't let that trip you up. If it's an ionic and you can suppress it to be a 1-to-1 ratio, like if this would be breaking down to a 10, it will be 1/10. It's just too common. You name it on your phone. You won't be asked to do that on the test. Do not forget about this one. Do not forget about this one. Okay. What about my last one? HF. Ionic covalent acid. It's an acid that I have an H in front. It's an elemental acid, a binary acid, so I have to have hydro, right? Hydro. What's it with? Chloric acid. Weirdly enough, a lot of people forget acid. Like not how to name acids, just the acid. Like forget acid at the end because I've done all that work to figure out what its name is. You can tell somebody something's an acid without giving the compound. I kind of like with that one.
Oh yeah, no, it's like I am gonna.
But you balanced it correctly. And the only thing that should have tripped you up was this one, which is something you will not have to name on a test, or probably even more. And you named all 3 of these guys correctly. Good. You did what is expected of you. Okay. So I now want to make you do the products. Because I honestly think it's more important than just balancing. So finish the reaction. I'm on that page. That's number 5. First, what kind of reaction is this? Number 5. Double switch it, right? Compound plus a compound equals a compound with a compound. Double switch.
So you never have to worry about like the metal or like you don't have to figure out metals.
You will find out charges later because you have to make,
Yeah.
obviously you have to make products here, but don't figure out stuff out unless you have an H in front of either of these. If you have an H in front of either of these, you need to check if it's acid base. Okay? Again, just a double displacement reaction with acid base, but if I ask you to give me the type of reaction, if you give me double displacement, it's technically wrong because we have to be more specific. Okay? So let's identify our cations and our anions. The way I remember cats is positives, is T was like a positive, cats, ions. I also like cats. But an always also means opposite. An in Latin is opposite, opposite to positive. Okay, so which one is our cation? It should not be a trick question. Ag is what? It is silver. So we know it's a positive. I don't care what its actual charge is yet. I just need to know it's positive. NO3 is a polyatomic. If I'm telling you this is an ionic equation, right? Because I have a positive, I have a cation in it, so it has to be an ionic equation, right? Then this has to be what charge? Negative. Okay. Look at this guy. Which one's my cation? What is the name of this polyatomic? You have to know it. Sorry, on your list. Let's sound it out. We have carbon, right? And we have what is left in this? Oxygen.
I'm gonna say, is it tricarbon? That's a-
There are no prefixes in my polyatomic. Okay. So we have carbon and oxygen. Oxygen as a suffix is just ate or ite, right? Ate and ite mean oxygen. Phosphate, I have an oxygen at the end. Phosphide, oxygen at the end. Sulfate, oxygen at the end. Okay. So I'm telling you that there's an ate at the end. We use our brains. What do you think comes from? Carbon. Carbonate. This works for a lot of them. What is in it? Oxygen. If oxygen is present, it is almost always going to be ate or ite. That's what oxygen is, right? And then whatever's in it with it, carbonate. Sulfate has sulfur and oxygen. Phosphate is phosphorus and oxygen. So this is carbonate. What do you think is the charge of carbonate? Positive or negative? Has to be negative, right? Okay. So I'm switching. Silver goes with that guy goes with that guy. Right? We switch our positives and negatives to make a new compound. So what is my first new compound? Doesn't matter what order they come in. Like the compounds don't. Your cations, your anions do. So give me a new compound. Silver carbonate, right? Okay. You have to know the charge of silver. Any guesses? No. I don't think so. It is part of our little triad in the transition metals: silver, cadmium, and zinc. Those are all the guys that you have to remember their charges for the transition metals. It's a positive one. The way I remember that is because I don't know why they didn't put the tape around these empty. I guess so you don't like, because this always says that during a test, so we don't want you to know you have to memorize those three. But if I have cadmium, silver, and zinc, cadmium and silver, or sorry, zinc and cadmium are both positive 2. They are on top of each other. 2 divided by 2 is what number? 1. 2 divided by 2 is 1. That's all I remember. They're all positive because they're metals. Okay. So we can figure out the charges of our polyatomics without having to memorize them if I give you a compound, right? So I'm trying to find out carbonate's charge. I know silver is a +1. Carbonate is with sodium. There are 2 sodiums for every 1 carbonate. What is sodium's charge? Normally. +1, right? And I have 2 of them. I have 2 plus on that side. So what charge does carbonate have to be? A -2. Okay? If silver is a +1 and carbonate is a -2, I need 2 silver for every 1 carbonate, right? To make them even. What's my next one? What is the name of that? Sound it out. What's it with? What's in it? Okay, oxygen has to be 8 or ite. Nitrates. I know that it's 8 because there is no NO4. NO4 is a neutral compound. Nitrogen can only take 4 bonds. Okay, if I have NO4, then it's a neutral compound. Okay, so NO3 is nitrate. Okay, sodium is a +1. What can we guess nitrate is? It's a -1. I know that because silver is a +1, so nitrate has to be a -1, right? Because they're a 1-to-1. 1, 1. Works. Okay. Is anybody here in Lions class? That's not a bad thing. I just have to pull this up then. I want to do states with you. You guys have to do states, right? Phases, solid, liquid, gas, aqueous, right? So let me not show you everybody's brain. Ugh. Oh. just show you this, because I don't have paper copies. Here we go. So, this is my solubility chart. I know it's a little fuzzy. But a solubility chart helps us predict what is aqueous and what is not. Okay? A solubility chart cannot tell us what a gas is or a liquid, but it can tell us if I'm aqueous or solid. Okay? So let's name the states of all of these guys. So Ag is silver. I want to look over here. Is silver listed anywhere here? No. So I have to go to the next guy in the column. I have nitrates. Is nitrate. Oh. So I am always soluble with no exceptions. So this guy is what? What does it state? Aqueous. Aqueous just means in water. It's an aqua water, aqueous in water. So it just means it dissolves in water. Okay? Let's look at our next guy. Why is sodium listed anywhere? Over there. No. So let's look at carbonate. So it's not soluble except for these guys. An alkali metal cation. It's sodium and alkali metal. Where are the alkalis? 1 and 2 are alkalis, right? Okay. Is sodium in 1 or 2? Yeah. Right? So this is aqueous, right? Because what this means is it's not soluble except when it's with sodium. Aqueous. What about silver carbonate? It is insoluble. If something is insoluble, what is its phase? Solid. Okay. Next guy. What about sodium nitrate? It is aqueous because it is soluble. If I have nitrate anything, it's soluble. There's no exception for it. Okay. I'm gonna ask you guys a question. Of these guys, which one is my precipitate? So let's talk about the word precipitate, right? What do you think of? Precipitation, right? Precipitation means what? Rain. And chemistry means the opposite. It means solid. Okay. Precipitate really just means something is coming out of something else. Rain is coming out of clouds. Out of your aqueous solution, I get a solid. This is my precipitate. I believe you will be asked that on the test. What a precipitate is and which one is it. And it's just a solid. It has to be a product. I make it. It's just the grime shit at the bottom of the glass. In lab, a beaker, and usually a metal falls to the bottom. That's precipitate. I want to ask you another question. Can you tell by looking at this equation if it's balanced? It's not. Right? I have 2 sodium over here, and I have 1 over here. So it's not balanced. So let's balance it. Okay. Let me erase these lines. Okay. Ag, do my polyatomics stay the same on both sides? They don't break up, right? So I can put them as 1, right? NO3 gets to stay together. Then we have sodium and carbonate gets to stay together. How many silver do we have on our reactant side? How many nitrates? How many sodiums? How many carbonates? Okay. On our other side, how many silvers do we have? 2. Nitrates? 1. Sodium? 1. Carbonate. We have 2 things to balance, right? Silver and sodium. Which one do you want to do first? Sodium. So this needs to be a 2, right? So when you put a 2 over here, what does that also affect? Nitrate. That becomes a 2. You need to treat your polyatomic like it is its own compound, right? You don't need to count them separately. You don't have now 6 oxygen and 2 nitrogen. So, what's next about? Silver and nitrate, yeah. So silver needs to be 2. So I put 2 over here. Doesn't that balance my nitrate? No, we're done. I know that was long, the whole thing, but I wanted to do states with you guys. Just a little touch on states. You will be given that insolubility chart on your test. Okay, do not need to memorize it. I didn't have to memorize it. So that would be horrible. So figuring out what a polyatomic charge is by the compound is important because I am realistic. You're not going to remember the charge of every polyatomic. I know you're not. It's okay. Instead, I want you to look at the compound it's with and see if you can tell that way. When I have a polyatomic with a transition metal, now that's hard, right? But I can still try to figure it out that way. And even a guess, you can be wrong. Okay, it's okay. You'll usually figure out you're wrong if you're making the products because nothing will balance. If I make my compounds wrong, like if I said silver had 2, a positive 2, right? I would have, this would be just AgCO3, right? There would not be 2 silvers over here, which means this would not balance right. Okay. This is one of our numbers. Okay. Remember your families on periodic table. And try to remember your polyatomics. I know people don't. I don't. I am. Let's do a single displacement really quick. Where we do the products, and then I have a word problem. Do people know difficult things with word problems? And I don't like that. So I try to at least do a couple word problems per lecture. Just because you might see them. So let's do number 6, one right below. So I have zinc plus H2CO3. H2CO3 is a polyatomic when it's an ion. That is not an ion. This is a compound that has no charge. Okay. So this is a neutral compound. So we're going to treat it like one. Okay. So zinc plus H2CO3. I first want to figure out cations and anions so I can see what I need to switch. So zinc is positive or negative? Positive. Hydrogen. Positive. And carbonate. Negative. So which one am I putting with carbonate? Zinc. What's left? H2. This is not because when in my balanced compound over here I have 2 H's. It's that way because hydrogen is diatomic. When it exists by itself, it exists 2. Okay. Now we need to balance our compounds to make sure they're correct. So what is zinc's charge? It never changes. And they positive 2, right? Positive 2. And it goes with carbonate. So what is carbonate? Carbonate's charge. I need 2 hydrogens for every 1 carbonate. Negative 2, right? Because hydrogen is normally positive 1, and I need 2 of them. So positive 2. So my other side has to be a negative 2. Okay. So if I have a positive 2 and a negative 2, 1-to-1 ratio, I'm good, right? Hydrogen's a diatomic, stays like that. Hydrogen is a gas if you're not cold different. It's a gas. You can't tell that from solubility charge. Okay. Zinc by itself is a solid. It's by itself. But we need to figure out H2CO3. Let me turn on my computer. So zinc's got up here, right? So we need to look at carbonate. Is zinc carbonate soluble? No. Because if I look at carbonate right here, it says it's insoluble except with these guys. It is not ammonium, and it's not an alkali metal, right? Carbonate is not, or zinc is not an alkali metal. So this guy is insoluble. Okay. Let's look at this guy. So again, we have carbonate, right? Alkali metal and cations. Hydrogen is what? An alkali metal. Well, it's because this is an acid. Acids are usually in solutions. So which ones are precipitate? Carbonate. Because it's our solid. Gases don't count. Gases and liquids are not precipitates, it's only solids. Okay? Those guys are just there. Okay. So. So let's make sure this guy's balanced, huh? Zinc, H, just carbonate stay together. I'm gonna count it with polyatomic. How many zincs do I have on my reaction side? Hydrogen, carbonate. How many zincs on my products? Hydrogen, carbonate. We're balanced, right? You do not have to put ones across the board. I don't need to. Okay. So it's balanced.
Do we ever have to name that hydrogen carbonate acid?
Yeah.
I'm like, no.
So this is an acid. This is a binary or ternary acid. What did I say binary acid? 2, which means I have hydrogen in an element, right? That's a binary acid. I have a hydro in front of the binary acid. A ternary acid has a polyatomic in it. Okay? CO3 is a polyatomic. This is a ternary acid. Ternary acids do not have hydro in front. Okay? All I do is I name my polyatomic. And I'm just going to put carbonate first because my suffix changes depending on what my polyatomic is. So I have ick and us for ternary acids. If something is icky, it is because you ate it. Right? So if it's carbonate, it turns into carbonic, right? Carbonic. If it's ite, it turns into us. It would be us. So it'd be if it was carbonite, it would be carbonous acid. So if you saw the word hydrocarbonic acid, wouldn't that sound weird? Sounds a little weird, right? It could exist, right? Because I have a carbon, it would be H. 4C. It exists. It's actually CH4. The name of it is methane, but that's a entirely different thing. We would name it like hydrocarbon. So, carbonic acid, no hydro, because I'm polyatomic. Polyatomic still the hydro. Okay. Name this guy. What's that compound, is it? It is polyatomic, but does that matter? Not if it's not an acid, right? So I have a positive and a negative charge. Ionic, how do we name ionic? Just say what it is. Zinc, and zinc's charge does not change, despite it being a transition metal, right? So it's zinc, carbon. I keep the 8 at the end of carbonate because it is not an element. I do not change it to I. If I say zinc carbonide, or chloride, whatever you say that would mean it was just carbon. That would be zinc 4C, or zinc 2C, right? Yeah. Zinc carbonate. This is just zinc. This is just hydrogen. Okay. I want to do a word problem. And then you'd like to feel free to take somebody of those back to be like. Usually when people study, sometimes they'll just do them over and over again. Number 4 on word problems 1. Aluminum and potassium metal and chlorine gas combine to form potassium chloride. Potassium metal. What does that look like? Just because something's metal, I don't know. So it's gonna be any state. I'm not asking you to name states here today. Potassium metal and chlorine gas. What does chlorine gas look like? Cl what? Chlorine is a diatomic. Do not forget those. If it's by itself, it's not an ion. If it's by itself and it's neutral, it is a diatomic with these guys. That is two. Okay. And it says forms. If I say forms or makes or whatever, or decomposes, whatever, arrow. Okay. The form potassium chloride. Potassium chloride. KCl. Do not put the 2 of the diatomic in there. That's not how compounds work. Okay. KCl. Potassium has a +1 charge. Chlorine has a -1 charge, so it's just KCl. Do not put the L as a big L. Okay. That's KC liters. Doesn't make any sense. Potassium carbon liters. No. Do not put a big L. Also, when you do your states and you write anything as liquid, it is a cursive lowercase L. If you put a 1, like a lowercase L in standard form, it just looks like a 1. Looks weird. Okay. So, but it's cursive, it looks like this. L does a lot of things in chemistry, so we have to be very specific. Okay. Is this balanced? No. Okay. So okay, CL. So I have 1, 2, and then 1 and 1. So what do I need to change? Chlorine, right? So I need 2 over here, which changes my chlorine and my potassium. So I need 2 over here. You will get faster. The only way to study for these guys is to do them. I wish there was a different answer. Chemistry, and especially with my nursing students or my ultrasound techs or dental hygiene, is you guys love flashcards. You love flashcards. It's everything. Your anatomy finals, flashcards, right? If I want to do bones, flashcards. If I want to remember vocabulary, flashcards. If I want to remember processes, flashcards. Isn't going to help you here. A lot of the time, unless you're trying to remember what the element names are, or you're trying to remember the polyatomics or stuff like that, flashcards are not going to work because they're only so big, and you're not doing them. The only way you can really learn some of the stuff in chemistry is by physically doing it over and over and over and over again. Even the ones you've already done, because trust me, you will forget how to do them. Okay. Every time you look at a balanced equation, think to yourself, is this balanced? Check 1. 2, what type of equation is it? Okay. Type 3, what are the names of the compounds that are in this balanced equation? Okay. Those are the 3 things you should be asking yourself in every equation. Because there will probably be a question on the test that says, is this equation balanced? What type of equation is it? Are these compounds correct? Do they exist? Some compounds do not exist because they're not balanced correctly, right? Like K2Cl. So, because I told you metal does not mean it's solid, I'm going to tell you it's solid metal. Gas. Cl2 comes in a gas at room temperature. And then we have KCl, you have to do a solubility chart for that to find out what type it is. Okay. So, you guys want to do another one of those? Okay. Pick one. Word problems 1 or 2. 2 are a little harder, I think, than 1. Number 2, word problems 2, what question? 2. Okay. In copper coil, what is the symbol for copper? Cu, right? Co is what? Cobalt. Is Cu diatomic? No. No metal except for hydrogen is diatomic. Place in a solution of silver nitrate. Do I put an arrow yet? No, because I'm placing something. There's no chemical reaction when I just place something. That's accurate. Okay. I place something And silver nitrate. We have silver. What is nitrate's formula? NO3. Does that balance? Silver has a charge of what? +1. Nitrate has a charge of -1. You have to do that. Right. So this is balanced, right? Okay. Silver crystals form on the surface of the copper. Cool. I don't care. Highly soluble copper is generated. Okay. The reason I don't care about that is because I tell you later more about it. That's why I say that. If something forms, then it's a problem, right? Silver crystals form on the surface of copper. Highly soluble copper 1 nitrate. So CuNO3. Is this copper 1 nitrate? Yes, right? 1, 1. Copper has a +1 charge, nitrate has a -1. Copper nitrate is generated with silver solid as a byproduct. Silver is antiatomic. What kind of reaction is this? Single displacement. If I say silver crystals, crystal also means solid, right? If I place copper coil, solid, right? Coil solid. In a solution of silver nitrate, what's my state for silver nitrate? Aqueous. If I say something is in a solution, or is a solution, solution means with water. Okay, so aqueous. Silver crystals form. Highly soluble, copper 1 nitrate is generated. I have told you it is highly soluble. So what does it state? AQ, right? So I've already told you it's highly soluble. You don't need to look at your solubility chart. Okay, so we have all our states. Now we need to check, is this balanced? So we have Cu, Ag, does nitrate stay together? And then we have, that's it, right? Okay, copper on my reactant side, how many? Silver, nitrate. Copper on my products? Silver, nitrate. Balanced? Yes. This is actually, this should be, for the average lab manual, this should be one of your lab. It is literally this. I take some copper, sometimes we throw a penny in there, take some copper, and you throw it in a solution of silver nitrate, and you create solid copper and nitrate stuck together, and it's blue. Copper is blue. So, and then you have silver as a byproduct, which will sit in thought. Okay. So, which is our precipitate? Silver. Would copper be a correct answer? Why? Because it's a reactant, right? Precipitates can never be reactants, they have to be products. I create precipitates. What's funny is the lab will actually be, what is the reaction? I place this and this together, what is the reaction? They won't tell you copper solid plus this is the solution equals this and this. You'll have to make the reaction by yourself. You'll have to think in your head, what is copper as a formula? What is silver nitrate as a formula? Equals what? What am I seeing? Okay. I like the next one. Sorry. Just reading through the next one, number 3 on work problems 2. What kind of reaction is that? Combustion. If something is burned, combustion. Burned in oxygen, especially. Your for company, you see a hydrocarbon, they don't like to just like later on. Okay. C6H12O6. C2H12O6. Right. That is not an carbon. Okay. Is burned in oxygen. What is oxygen's formula by itself? O2. Number 2. When it is burned, that means I have an arrow. Carbon dioxide and water vapor are formed. What does carbon dioxide look like? CO2. Water vapor. H2O. Do I care about the vapor other than for a state? Does water vapor stay in vapor change my chemical formula? No, because it's a physical change, right? Physical changes do not change me chemically. So if it's vapor, what is it? Yes. What is CO2? Gas, right? What do you think of 2 is? C6H12O6 is the thing we don't know. And you could write that as hydroxide, kind of, if you really wanted to look at the solubility chart and figure out. But I know it's not gonna be a precipitate, so I don't care at this moment, right now. For this, your teacher might care, but I do not care. It's not gonna be a precipitate. Okay. So, combustion reaction. Is this balanced? Is the combustion ever balanced? Okay. CHO. How many carbons on my reactants? 6. How many hydrogen? How many oxygen? 8. What about my products? How many carbons? 1. How many hydrogen? How many oxygen? 3. Which one are you not going to do first? Oxygen, because it is in 2 on both sides. It's even trickier. Okay. So, which one do you want to do first? Doesn't matter. Carbon. Okay, let's do carbon. So I want this one to be 6. Oh, because I have 1 carbon over there. Yes, right, 1 carbon. So that becomes 6. How many oxygen do I have? Don't forget that guy. It's 13. Okay, what do you want to do next? There's the right answer. Hydrogen. So we need this guy to be 12, right? So I need 6 over here, which changes my oxygen again. I still have 12 over there, right? And now I have 6 over here, which makes 8. These guys are balanced, carbon, hydrogen, so I just need to think before I make any marks on it. I have 6 oxygen over here. If I put any number before this will mess with my carbon and hydrogen numbers. I do not want to do that unless I have to. Okay. So I have 6. So 8 minus 6, or sorry, I want to get to 18, right? So I have 6 over here. 12, right? So I need how many oxygen on this one? 6. That makes me 18. Do not mess with your hydrocarbon unless you have to. Okay, because you then mess with everything. Mess with hydrocarbon. And because I have a 1, 6, 6, 6. Very good. Am I going to downsize anything? Am I going to simplify anything? No. No, right? Because 1 cannot be divided by 6. It'd be 0.17. Okay. So this is a combustion reaction. This is a pretty classic combustion reaction. I don't know if they're going to do a hydrocarbon with an oxygen, but it's really no different than doing one without an oxygen. Don't freak out. I think you guys can think about that. Now, this is your space to ask me any question that you want to ask me. It does not have to pertain to balancing. It could. It does not even have to pertain to the exam you're about to take, but it probably should. Yes. Yeah, we can do electron configuration. Do you understand electron configuration versus electron orbital theory? So we have one that has arrows and we have one that has numbers. Okay, if I ask you for electron configurations, I'm going to ask you for the numbers, right? With the sublevels. Okay, sublevels are our letters. S, P, D, F. Okay. The other one, orbitals, I'm worrying about those up and down arrows. So we're going to do the arrows and the numbers for one element. Okay. So pick an element. Magnesium. You want it to be neutral? Do you want it to have a charge? Neutral. Okay. So it's just the atom magnesium, it's not the ion. So how do I know how many electrons are in magnesium? It is on the periodic table. What number is on the periodic table? It's 12. Protons and electrons equal each other when it is a neutral atom. Okay, so it's always going to be your atomic number if it's neutral. Okay. I write that down because my little superscripts, the numbers up top when I write this up, should equal 12. Okay. Where do we start with electron configuration? What level? Sublevel. We have S, P, D, and F. Where do we start? S. Where is S? What groups are S? Groups are vertical. 1 and 2, right? Groups 1 and 2 are going to be our S orbital. So do we start at 1 S? Okay. How many electrons fill up the S sublevel? 2, right? So this number cannot be 3 up here. It has to be 2. Because it goes beyond that. So I know 1s is full. So 1s2 means full 1s orbital. Okay. What's our next sublevel? 2s, right? There is no such thing as 1p, right? So 2s is 2s full. Yes, because we go beyond 2s, right? What's next? What's our next sublevel? Go directly horizontal for 2s. I hit 2p, right? 2p can have how many electrons in it? 6. If you ever forget that, count the blocks. From 13 to 18 is 6. 1, 2, 3, 4, 5, 6. Okay? Do I go past 2p to get to magnesium? Yes. So it's a full orbital, right? 2p6. Okay? What's next? 3s. Okay? 3,1 would be sodium, or 3s1 would be sodium, and 3s2 would be magnesium, right? 3s2. Now, how do I make sure that I counted right? Count these guys. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. 12 electrons, actually 12 up here, I'm good. Okay. Now, what are my valence electrons? These are our valence electrons. Valence electrons are your highest sublevel. Look at your numbers, not your letters. Okay. If I had more 3s, like if I went down to 3p, I would count those 2. Okay. They're just your last of the highest number. Okay. And you combine all the same numbers together. Okay. Valence. So remember that it's your outer. If you ever heard of like valence curtains, right? They're real high curtains, they're real short. They're high. They're my last level. Valence curtains. You're raised by your brother, I guess. So those are our valence electrons. So how many valence electrons? Yes. We have 2 valence electrons. And magnesium. So let's do the arrows, huh? We have to puncture up the sublevels for our arrows by orbital. So I have 1s, 2s, 2p, and 3s. Every block is 2 electrons. Okay? So I only have 1 here, right? So I can write 2. 1, 3. That's 6, right? And then 1s again, just that's 1. Sometimes you start from the bottom, 1s, and then go up. Do however they like you do. Okay. So when it comes to electrons, I have one that spins up and one that spins down. The reason for that is electrons are always negative, right? Negative repels each other. Anything of the same charge repels each other. So I have one that goes at the very, very top of my block and one that goes at the very bottom. So up, down. Ups are always first because they're separated by block. Okay. 1, 2. I have to go by sublevel. I'm not just going to fill in all of them with up arrows and my down arrows. So that's 2 electrons taken care of. I have 2 more, 4. And then here's what I mean. All those up arrows have to go first because it's not always filled, right? But 2p is filled, right? Like 6. I put mine down. And then I have a full 3s. Those are my 2. That's how we do the arrows.